vehicle towing a caravan accelerates at 1.8 meters per second squared in order to overtake a car in front. The vehicle's mass is 2,700 kilograms and the caravan's mass is 2,000 kilograms. The drag forces on the vehicle are 1,100 newtons, while the drag forces on the caravan are 1,500 newtons. A, calculate the thrust of the engine. Now again, there's a lot going in our worded problem here. So let's simplify it. Let's draw a diagram. So, why is this not working? Hang on, bear with me. All right. So you should be able to draw a little car there. Well, it says vehicle, so we don't know it's a car, but let's assume it is. There's our caravan. We have a car. Oh. You're going to get used to my horrible diagrams, I apologize. Car pulling a caravan like that. Now, we put in the information we know. We know the caravan's mass is 2,000 kilograms. We know the car's mass is 2,700 kilograms. We know that we have drag forces. So on the car, it is 1,100 newtons. Oh, this is so squashy. Sorry, I need to give you more room. 1,100 newtons. And on the caravan, a drag force of 1,500 newtons. And our key point is the acceleration of this whole system is 1.8 meters per second squared. Okay, so there's our diagram. So now we want to calculate the thrust of the engine. So when you hear something like this, the thrust is basically the force that is pulling everything forward here. The thrust of the engine is responsible for moving the car and the caravan forwards. Okay? And in fact, not just moving them, it's accelerating them. We have an acceleration of 1.8 meters per second squared. Okay? So going back to Newton's second law, we know that our net force is equal to ma. Okay, so the sum of all of our forces is equal to mass times acceleration. Now, in this case, when we're talking about mass, we're talking about the mass of the entire system. Okay, because we're talking about the acceleration of the entire system as well. So the mass of our entire system is 4,700. It's the mass of the car and the mass of the caravan. So the mass of our entire system is 4,700, and the acceleration of our entire system is 1.8.
8460.
Thank you. 8460 newtons. Now that is our net force. Okay, our net force. So the sum of our forces is 8460. Now, anytime you have a net force question, and you're asked to find a particular force within that net force, so in this case we're looking for the thrust, but there are other forces going on, we might want to set this up and define what our net force actually is. So our net force is the sum of all of our forces. So we don't really need to worry about gravity or the normal force here. Those aren't impacting the motion of our vehicles. But what are our horizontal forces acting? Friction. All right, so we've got, I'm just going to call it drag, because the question calls it drag. And what else? Thrust. Okay, so a net force is made up of the drag and the thrust. It's all of our forces added together. Okay? We are looking for thrust. So we need to rearrange this a little bit. Okay, so we get thrust is equal to our net force minus our drag force. Okay, so I've just rearranged this question a little bit, subtracted drag force from both sides. So we get our thrust is equal to our net force minus our drag force. Okay, we know what our net force is. We worked it out over there. So our net force is 8460. Now here's where we need to be a little bit careful. We're going to deal with negatives quite a bit in problems like this. Now a negative in physics, we said that we can't have a negative force. We said this yesterday. There's no such thing as a negative force. We can't have a negative mass. We can't have a negative, time. So when you get a negative in physics, it is talking about direction. All right? If left is positive, right is negative. Okay? That's what it comes down to. So in this case, our net force is positive. So let's call that way positive and that way negative. So we know that our net force is positive, 8,460. Our drag force, is it going to be positive or negative? It'll be negative because it's towards the right. So if we look at our equation down here, our thrust is equal to our net force, which we've got, minus our drag force. But our drag force is already negative. So it's going to be minus a negative. So minus our negative drag force of 2,600. So therefore our thrust, 8,460 plus 2,600, will give us basically 11,000 newtons. To a couple of significant figures. Okay, now this sort of makes sense. So one thing that I'd like you to do, when you do a problem like this, apply what I call the common sense rule. Okay? Is our answer logical? So we think about this. Our thrust is 11,000 newtons. Okay, so our engine is providing 11,000 newtons of force to the left. Our drag force, we're losing 2,600 newtons of that to friction. Okay, so we've got 11,000 newtons from our engine, we're losing 2,600, and so that leaves us with our net force, which is what is accelerating our whole system. Okay, so that's what I mean. Just look at it. Does it make logical sense? And in this case, it does. Okay, our thrust is this. Our thrust needs to act a little bit over what it would because it needs to overcome that friction. Okay, so that's why, yeah, our thrust is 11,000. We lose 2,600 of that to friction. That's what's left. And what's left is our net force that gives us our acceleration. Okay? All right. The next bit is a little bit easier, even though it seems a little bit complex. Okay, so we want the magnitude of the tension in the coupling. Now, tension is a pulling force. So when we're looking for the tension in the coupling, we are looking for the tension in that bit there. Okay, what is the pulling force of that bit? Now, there's a couple of ways to calculate this. Let me show you the easiest. Let's ignore the car for a second, and let's just look at our caravan. What do we know about our caravan? Well, we know its mass. Its mass is 2,000 kilograms. We know it has a drag force acting on it of 1,500 newtons. We know it is accelerating at 1.8 meters per second squared. The only thing that is pulling it forwards is the tension. That's the only thing pulling it forwards, is the tension. So we can ignore the car totally here. Okay, the car doesn't matter. All we're looking at is the caravan. And in fact, anytime you have a tension question, this is what you should be doing. Ignore what is doing the pulling and only look at what is being pulled. Okay, look at that, isolate that one little aspect of the problem. We look at our caravan here, we have a lot of data on it, and we know the only force pulling it forwards is the tension force. There is no thrust acting on the caravan. The thrust acts on the car. Okay, the caravan only has the tension force. And so from here, it's another Newton's second law problem. So the sum of our forces is equal to MA. We know what MA is. So we've got 2,000 multiplied by 1.8. So that's 3,600. So our net force is 3,600 newtons. Again, our net force is made up of our other forces. So our net force is made up of our tension force plus our drag force.
Do we have to donate? Donate. Normally, last year we just wrote T, big T, for tension.
You didn't do F subscript T?
No. Does it matter?
No, not really. No, I'm trying to think, does capital T mean anything else we're going to use this year? And probably not. I tend to do it like this, so we know we're dealing with forces. Okay? But yeah, I mean, if you want to use a different sort of, symbol system, feel free. Okay. So if we want our tension force, again, that's just our net force minus our drag force, which is 3,600 minus negative 1,500. So our tension force will be 5,100 newtons.
That makes sense. That does make sense.
The logical sense, yeah. So our tension force has to pull it forward, and it is losing 1,500 newtons. So we've got 5,100 pulling it forwards, 1,500 pulling it back. What is left is used to accelerate our caravan. So anytime you have tension, like I said, just look at what is being pulled. Don't look at what is doing the pulling. It makes it much more straightforward. There is another way to do this, just if you're curious and if you want to give yourself an extra challenge, you can try this. You can calculate tension by only looking at the car, okay, rather than the caravan. And so what you would need to do is look at the thrust from the car, look at the force pulling it forwards, look at the friction force pulling it back, but also you'll realize there has to be another force pulling it back as well, and that will be the tension force. Okay? You can work it out both ways. This is the easiest way to do it. But if you want a challenge, try it the other way as well. All right. So that one's a little more